So, hello everybody, thank you to assist our talk. So in this presentation we will show you how CompatibleOne interacts and provision PaaS resources from heterogeneous PaaS providers. So I begin with the context of our work. The PaaS provisioning resources requires the use of specific and proprietary APIs, which are exposed by the PaaS providers. For example, if we want to provision a sample web application on an existing PaaS provider like OpenShift or Cloud Foundry, we have to provision Apache Tomcat container and a MySQL database node to host and execute this application. So meanwhile, the provisioning steps to provision these resources are not the same from one PaaS provider to another. In fact, they are not have all the same deployment scenario, not have the same exposed operation, and not have the same inputs. However, they have all the same semantics. So as part of our work, we have designed and implemented an OCCI compliant generic API to provision platform and application resources from heterogeneous PaaS providers. So this API, we call them COAPS. COAPS stands for CompatibleOne Application Provisioning Service. So COAPS, it's an independent, PaaS-independent approach for provisioning and management of application in a PaaS. So here we have a manifest application to manifest to describe application through a defined description model that we have defined as part of our work. And here we have the generic RESTful API, which exposes generic interfaces in the site for the cloud consumer. And on the provider side, they exposes specific implementations depending the proprietary API providers. So the demo consists of provisioning our motivating example, the sample servlet application on Cloud Foundry PaaS providers.
So for the demonstration, we'll show how we provision an application to how presented my colleague Sami. So it consists of a sample servlet that we want to deploy on a Tomcat container using a MySQL database. So we will start by activating our server OCCI COAPS API. Then we will use a REST client to send queries. So to start, we will prepare the environment to deploy our application. It consists of a Tomcat Apache and a MySQL container. So for the MySQL database, so for the container, we will start by filling the attributes. We will need to specify the name and the architecture of Tomcat. Then we will send this query to our server. So we need to save the information, the identifiers of the container that we will use later. After that, we need to prepare the database information. So we describe our database. We need a MySQL. We specify the version, the architecture, and the type of the database. So we send the same the query to our server. Then we get back the information and we save the location of this database, which serves as an identifier of this database. Then we need to link the container that we created and the database using a link that we defined. It's an OCCI link that we call database link that allows to link a database to another resource like containers or routers. So here we specify the container and the database. Afterwards, we save this information that serves as identifier of the link. And we are ready to create the environment that consists of this collection of containers, databases, and links. So here for the environment, we can specify the name of the environment and all the attributes related to this resource. We can specify the memory that will be used and allocated by the PaaS provider to our application. Here we'll specify that it will use 128 megabyte, and we will specify the list of containers. In fact, an environment can contain one or more containers, one or more database, and eventually the links between these resources. So here we will use the identifiers that we already saved. So now we have all the information related to environment, and we are ready to deploy an application in this environment. So we will prepare our application using our described resources. Then we will be able to deploy this application to the prepared environment. So for an application, it may contain one or more deployables. A deployable can be a zip file or a WAR file. In our example, we will use a WAR file for a servlet. So we specify the name of our deployable and its location and its type. Here we have the information related to the created deployable. We save the location and the identifier of the deployable. So before creating the application, we open the interface of Cloud Foundry, which is the path that we choose to deploy our application. So now we can create the application instance, so using the deployable that we prepared. So we specify the name of the application, a small description of this application, and we can choose the number of instances of application we can deploy, as many instances as we want. Then we will specify the list of deployable that will compose our application. So here we have the application resource is ready, and we are able to deploy this application to the existing environment that we prepared before. To do that, we will need to create an environment link, which is an OCCI link that will link the application to the environment. So for a link in OCCI, we have to specify the source and the target. Here, our source is the application, and our target is the identifier of the environment. So the creation of an environment link between an environment and an application consists of deploying the application to this environment, and we can verify this in the interface of Cloud Foundry. Here in the interface, when we actualize, we will see that we have already created an application with the specified attributes with the memory 128. And we see that we are using a MySQL service. So now we can use the identifier of the application to activate actions. So here we will to start the application, we use the identifier of its identifier, and we send a query with the start action. So here in the OCCI server, we see that we received a start action to activate our application, and if we verify in the Cloud Foundry interface, we receive that the application is available now, and we can see it in the Cloud Foundry console. So here the application is starting. We have two instances, but just the first instance is running, and the second one is still running. And we can access this application to use it. So essentially, that's how we use this our description, our OCCI complaint API. To deploy application in different PaaS providers using the same description. So if we want to deploy our application, the same application in an OpenShift provider, we'll use the same demarche and the same steps that we use it here, and the same model of the description. Yes, there is an implementation of for Cloud Foundry for the moment, and for OpenShift. There is another one from Egyptian partners that is working on Google App Engine. There is a fourth implementation that is in progress that aims to use this our API to deploy application in upscale.